Right. Hello. Is right. After hello party stream or UIUCTF 2023 finished about half an hour ago. To start off, I would love to give a huge thanks to all of our sponsors. We had Battelle, Zelic, Davidon, and Trail of Bits all sponsor us for UIUCTF. We also had a generous contribution of infra from Google Cloud through their CTF sponsorship. SIGPwny is extremely grateful for them helping us fund this event for yet another year and helping us fund a massive prize pool. I would also love to give a huge thank you to the UIUCTF team and all the challenge developers, our project managers, Emma and Sam, our alums, Yifei, Ankur, Kuilin, and Ravi, who is here to make sure this CTF is even running, and some awesome challenges as well, and the awesome theme that we had this year that was made in great part by Pete, Min, Kuilin, and infrastructure with Yifei. So stats, we had a record-breaking 2,400 users combined into almost 1,300 teams. Had at least 618 teams with solves. Have some submission stats as well. We had 5,200 submissions that were solves and almost 25,000 fails. I'm going to guess that most of those were from OSINT. Our miscellaneous had the most challenges because we had 4 Vim jails and a bunch of other challenges in there as well. But our Pwn and Crypto had a lot of solves in the technical region as well. So prizes. For first place, we have $2,048. Second place, $1,024, decreasing powers of 2. Prizes get spread out across 4th and 5th and 6th through 10th. We also have a write-up pool of $1,500. 150 of those dollars is $150 of those dollars is reserved for a write-up for Fast Calculator, because that write-up pool is sponsored in most part by Battelle. If you are in the top 10, expect an email from us very soon. Give you 3 weeks to reply before the prize goes to the next team waterfalling down. If the email you've registered with on CTFD is unreachable, please open a ticket with us with Clippy mod mail as soon as possible. So, congratulations to our top 10 teams. Blue Water, Spotless, Project Sakai, Mount AIN, SNHT, Maple Bacon, Babbage Patch Kids, Vespiary, 796F75, and Zero Tolerance. Wonderful work these last 48 hours. It was amazing to see some of these solves come out, especially for some of our hardest challenges. We also want to talk about the write-ups and repo release. So 1 week from today, there's a write-up submission form currently available on the Discord. 1 week from today, all of your write-ups are due to be eligible for prizes. We have $1,500 in funding for those prizes. Again, 150 of which is reserved for Fast Calculator. We are looking for well-written, explanatory write-ups, something that someone with familiar prerequisites could read your write-up and solve a challenge of a similar type, right towards an expected audience. So if you make a write-up for the baby pwn challenge, expect that someone knows how to code, but maybe not necessarily what a buffer overflow is or how the stack is organized. On the flip side, if your write-up is for a mock kernel, expect that most people know how to do heap pwn and things like that, but now in a kernel user setting space. It's the main part you should be explaining. Following the write-up deadline, we will immediately release the challenge repository with all the sources for all the challenges, along with solutions by the challenge authors themselves. Now we're going to talk through a few of the challenges by some of the select challenge authors. Min is the one who wrote Fast Calculator. However, I will quickly talk about some of the aspects of that challenge. The binary that was given was compiled with the flag fastmath. This flag does enable a bunch of floating point operation optimizations, one of which is finite math flag. That flag compiles out any isNaN or isInfinite operations, and it just makes those functions return 0 if they're ever called. In that case, there was a bit of work to do with patching and figuring out what was going on under the hood, but we'll leave you to figure that out for your write-up still within the next week. And now Yifei for his 3 challenges.
Do I just unmute and speak?
Yep. Go for it.
That should be fine, yeah.
Oh, so let me switch this. Okay, am I not root? So am I not root? This challenge, what it does is, it puts you in a jail, which you have the same. You are in a different user namespace and don't have capabilities as host, but you can write to the complete host file system with the true root capabilities. What you can do, okay, so there's a hint where I said I patched out core dumps and I patched in like this. I disabled core dumps and I disabled what's the other thing I disabled? Margin loading. Both of these are facilitates user container escapes by giving user mode helper. What user mode helper in the kernel does is it uses kernel capabilities to create processes with highest capabilities outside of any container. But there's another thing is that's the key request system, a syscall call request key. The syscall does is it will invoke a binary executable at a fixed location in the root mount. It's called sbin request key. You can just write to it and you call the request key syscall and you're done. Yeah. That being said, UID 1. So a lot of people got confused on this challenge where they just linked and it didn't work. So glibc has a patch where it's like an additional defense against the CVE linked, where if you run the executable in set UID mode and it expands rpass containing origin and sees that the new rpass is in an untrusted path, like mostly just not user lib, then in that circumstance, it will refuse to use the rpass. The workaround here is that my loader does not care, does not have the additional, does not care about like this whether it's set UID or not. It will load the ld.so anyways, the dynamic loader. It will always use it relative to the current path. So when you do this hard link, overwrite the LDSO and you're good to go. That being said, UID2, this is complicated to explain. So like the idea here is that you can create a new user namespace that contains another mount namespace. You can do the crazy stuff with the mount tree. And in the original user namespace, so when you enter a user namespace, you are essentially locked yourself into that user namespace and set UID will no longer work. So you have to get the parent process, which is in the original parent process of the exploit. So in the parent process, it will try to open tree against the new user namespace, mount namespace, which has been modified with bind mounts, and do an open tree to detach the tree from the mount tree, and then you can use exec ve@, to perform an exec on the new what's it called, new pass. You modify the pass, so you again fool the read link syscall and then you get the exploit. all we need to do is somehow fool the read link. Hard link is one way, and the user namespace is the other way. But to do the user namespace way, you have to like patch the kernel. So like I was initially thought of this method, and then it didn't work. So I had to debug the kernel to figure out where exactly I had to patch without making it too easy. And then that's how it went. And then yeah, it worked.
I can't hear Quaylin's audio. I don't know if that's a me thing.
Hello, hello.
Yeah, I can hear you now.
Okay, great. So first of all, there were complaints that FutureDisk should not have been a web shell. I kind of agree with that. In hindsight, it's more of a misc, or maybe even forensics in reverse engineering gzip streams. And anyhow, the idea of FutureDisk is that you have a gzip stream that's basically all zeros, except somewhere randomly in the middle, you don't know where, there's the flag. So what happens when you pipe gzip into what happens when you pipe a stream of zeros into gzip is that there's a finite amount of states, so it's going to start repeating. The deflate chunks that represent the zip zeros will start being identical. This means they're going to start rotating modulo a certain large size. And when the gzip utility encounters the flag, it will obviously generate a different chunk that's likely a different size, which means if you use an HTTP range request to seek like somewhere near the beginning and then somewhere near the end, and then modulo it by the chunk size that you determined by just downloading a bit of the stream, then you can determine where the flag is by binary search, because the chunks that are after the flag will be a different the chunks will be offset by a different number of bits modulo the number of bits in the in the zero block compared to the ones before the flag chunk. So my intention with this challenge was that you reverse engineer the gzip stream, because there's deflate streams are cool, and there's not that many good tools for working with them dynamically, especially on the level of how you have to have how the individual bits go into the bit stream. Because if you just naively like interpret all of the bytes as binary and concatenate the binary, your endianness is going to be off. So my hosting for this, the infra actually, he has its own bit twiddling stuff. So the idea behind FutureDisk 2 is that there's a cheesy way of doing FutureDisk 1, which is to disregard the idea that the deflate stream is a bit stream and just pattern match by the bytes. And since there's 8 bits to a byte or something, you can modulo by 8 times the amount and get to a rough vicinity of the flag. So what FutureDisk 2 does is it varies the number of bits in each block of zeros. So basically, inside the deflate stream, there are deflate instructions, and these deflate instructions can either be output this constant, or output this constant from a Huffman table, or look back at the previous output that has been outputted for a certain number of bytes, and then repeat this basically substring of the recent history. And so what the zero chunks basically did was first output a literal zero, and then a lot of basically repeat the last byte that I output the maximum number of times, and the maximum number is like 250 or something. So that's why if you like naively scroll through it, there's a lot of U's, because U is OX55. OX55 is 01010101. That's because instruction 01 is just to repeat the last byte after being encoded by the dynamic Huffman table. So what FutureDisk 2 was vary the amount of match instructions inside each deflate chunks. So the first chunk would have 3 match instructions, and the next chunk would have 4, and then 5, and then 6, all the way up to 32K. And then the one following that would start at 4 and then 5 and then 6 all the way up to 32K, and then 5 and 6 and 7 and all the way to 32K. And so in this way, the actual repeat is somewhere on the order of a 10 to the 19, I think. I'm not sure about that, but the repeat is very big. So you have to actually know how to do the bitwise calculations in order to determine what bytes a certain offset is going to output. This involves representing the arithmetic series as a sum of an arithmetic series. It becomes a cubic polynomial, and then you just reverse that polynomial. And then once you have a formula for calculating what bits should be at a certain offset of the stream if the flag didn't exist, then you can binary search by just comparing, oh, hey, there's either the bits match, in which case it's before the flag, or they don't, in which case it's after the flag. And then after that, the methodology is the same as future disk one.
Kuilin, on to Nitya for a corny kernel.
Hi everyone, I'm Nitya. Next slide. So Corny Kernel is a beginner challenge aimed at teaching what a kernel module is and how to load a module into the kernel, how to remove it, and how to view kernel logs. So the basic idea is that modules are, pieces of code that can be loaded into the kernel to extend its functionality or to add support for hardware devices or other features. So first, when we connect to the challenge, it spawns a root shell, because in order to load and unload drivers to Linux, we need root access. So anyway, after we unzip the file, we have this .ko file, which is the compiled binary form of the kernel module. And since we already have the .ko file, all we have to do is load it into the kernel at runtime using the insmod command. And that's spelled INSMOD. To verify that we've, inserted this driver properly, we can use lsmod, which will show us the status of all the modules that are currently running on the kernel. And the module can be then dynamically removed using the rmmod command. So anyway, to get the flag, it's pretty simple. You insert the module into the kernel with insmod, remove it with rmmod, and extract the flag using dmessage by looking at kernel logs. And that's it.
On to Pete for about Rattler read.
Yes, hello everybody. So my challenge was a Python jail. We did not have Kevin here to make a Python jail, so I figured I'd step in. So just a little bit of context. About a year or two ago, I had an idea for a Discord code execution bot that was quickly broken, and I had used restricted Python for the execution of the bot. Anyways, we had found this 0-day in restricted Python where it doesn't properly sanitize the string module. So I have the exploit on the screen here. The original exploit was discovered as a string.format with an environment variable leak. And then this was later changed into requiring you to get full command execution. I believe there was another solution involving stack frame backtracking that has been posted in Writeups. That was not the intended solution, but that is also an equally valid solution. Yeah, another cool thing is that since restricted Python imports random in their own code, you don't need to import it. And if you'll notice, I even blocked imports. So you have to use the get field on random or do some other shenanigans. If you have any questions, feel free to put them in public FAQ or on stream. Oh, I also helped with the theme. So if you guys have any quick questions about the logic behind the theme, feel free to drop them somewhere as well. Thanks.
Pete. that will be all of our challenge demos. We're excited to see write-ups that you week. Once again, I want to give a huge shout out to our sponsors, Bell, Zelic, David On, Trail of Bits, and Cloud. We hope to see you at UIUCTF 2024. This CTF was an absolute blast. And thank you everyone for coming out and competing holiday weekend if you're in the States or if you're in Canada.
Yeah. Thank you everyone for coming out.
Bye all.